Welcome. What we're going to do is do a tutorial on finding the extreme values of a function on the interval and where they occur. Okay. Here is an example of h of x equals natural log of x plus 1 on the interval from 0 to 3. Now, when you're trying to find extreme values are generally what we refer to as max and mins. Okay. Max and mins. Now, when we have max and mins, we are looking for either absolute or relative. Now, generally, when you have a function, what we're going to do is we're going to look at this function and determine if we're going to find absolutes or if we can find absolutes or relative max or mins by looking at the function and see if it has closed intervals. Well, first off, we have natural log of x plus 1. Okay, natural log of x plus 1, and it's on a closed interval from 0 to 3. All right, because this is on a closed interval, okay, closed interval, and we also have a continuous function on this interval, okay, we are guaranteed by the extreme value theorem, that there will be an absolute max and min on this graph, okay? And so what we're going to do is we're going to identify these max and mins, all right? According to the extreme value theorem, we know that's going to occur, so we're going to identify them. Now, to do this, the first thing, absolute max and mins occur at endpoints and critical points. So, the first thing is we're going to test our endpoints. Now, to test the endpoints, what we're looking for, remember, are absolute max and min. So we're looking for the value of hx that gives me the largest value and the smallest value. Now, to find the value of the function, we're simply going to take our endpoints, in this case 0 and 3, and we're going to plug them into the actual function to find out what the value actually is. So when we plug that in, we're going to have this is the natural log of 1. Now, the natural log of 1 is equal to 0. And now we're going to plug in 3, and we have the natural log of 4. All right, 4. And that's just the natural log of 4. Now, if we would stop here, we would notice that 0 is less than 4, so this would be my absolute min, all right, and this would be my max. However, we also have to identify our critical points if there are any. So from here, we're going to take the derivative then, because remember, critical points, I'm going to change the color here. Our critical points are where h of x equals 0 or where h prime of x, all right, does not exist. And we'll call that DNE, does not exist, or it's undefined. So to identify this, all right, we're going to find the derivative of h prime of x. So derivative of h is going to be 1 over x plus 1. Now looking at this, we're going to identify where does it equal 0. Well, this never equals 0 because we look at the numerator. And that never equals 0 because 1 never equals 0. And now to find where it doesn't exist, all right, where it does not exist, we look at the denominator, when the denominator equals 0. Now in this case, we do have a denominator, so x plus 1 equals 0, and x equaling negative 1. Okay, well looking at this critical number, we identify that it is not in the interval, all right, the closed interval that we have, so guess what? There are no critical numbers or critical points that we can use. So I guess by default, this only occurs at endpoints. So I guess we have an absolute min, all right, at 0, 0, 0, and we have an absolute max at natural log of 4. And that's how you can identify extreme values using the extreme value theorem and when you have a continuous closed interval function like we have here. I hope this helps out, and there will be some more tutorials coming up.